Hi students, here is the ninth question of the exercise 13.2 and the question is if A and B are two events such that probability of A is equals to 1 by 4, probability of B equal to 1 by 2 and probability of A intersection B is equals to 1 by 8, then we need to find the probability of not A and not B. So in this question we need to identify the value of probability of not A and not B. So firstly we need to write this mathematically. So that's why probability of not A is written as A dash or A complement and is nothing but intersection and not B is nothing but B dash or B complement. Now by using the De Morgan's laws, we know that the De Morgan's laws are A union B whole dash is equals to A dash intersection B dash R. A intersection B whole dash is equals to A dash union B dash. So by using this De Morgan's law, probability of A dash intersection B dash can be written as probability of A union B whole dash. So by using the first law, probability of A dash intersection B dash is equals to probability of A union B whole dash. And we know that one of the property probability of A plus probability of A complement plus probability of A dash is equals to 1. So by using this, probability of A dash can be written as 1 minus of probability of A. So by this, probability of A union B whole dash can be written as 1 minus of probability of A union B. And we know that probability of A union B is equals to probability A plus probability of B minus probability of A intersection B. And just substitute the given values of probability of A, probability of B and probability of A intersection B. So 1 minus probability of A is 1 by 4 plus probability of B is 1 by 2 minus probability of A intersection B is 1 by 8. Now see here, this is equals to 1 minus, here I can take LCM. LCM of 2, 4 and 8 is 8. So here multiply by 4 into 2, 8. Here 2 into 4, 8. Here 8 into 1, 8. So 1 into 2 is 2 plus 1 into 4 is 4 minus 1 into 1 is 1 divided by LCM is 8, which is equals to 1 minus 2 plus 4 6, 6 minus 1 5, so 5 divided by 8. Again here I can take LCM. So here multiply by 8, here multiply by 1 because LCM of 1 and 8 is 8. So 1 into 8, 8 minus 5 into 1, 5 divided by 8 and which is equals to 3 by 8 is the required probability. That is the probability of not A and not B. I hope all of you understood this question. Now let's start the next question. And the next question is events A and B are such that probability of A is equals to 1 by 2, probability of B is equals to 7 by 12 and probability of not A or not B is equals to 1 by 4. Then we need to state whether A and B are independent or not. So as you know that two events A and B are said to be independent events if A probability of A intersection B should be equals to probability of A into probability of B. If probability of A intersection B equals to probability of A into probability of B, then only we call that A and B are the independent events. So to identify whether A and B are independent or not, so whether we need to check whether these two quantities are equal or not equal. So for that directly he has given probability of A and probability of B. But to identify the value of probability of A intersection B, here he has given one information, that is what probability of not A or not B is equals to 1 by 4. And probability of not A can be written as A dash. R is nothing but union and not B is nothing but B dash is equals to 1 by 4. Now by using the De Morgan's laws, probability of A dash union B dash can be written as probability of A intersection B whole dash, and which is equals to 1 by 4. And we know that probability of A dash is equals to 1 minus probability of A. So therefore by using this, probability of A intersection B whole dash can be written as 1 minus probability of A intersection B, which is equals to 1 by 4. Now by this, probability of A intersection B shift to right and 1 by 4 to left. So 1 minus 1 by 4 is equals to probability of A intersection B. Now on left side we may take the LCM. LCM of 1 and 4 is 4. So here multiply by 4, here multiply by 1. So 1 into 4 is 4. 1 into 4 is 4. Minus 1 into 1, 1. Divide by LCM is 4, which is equals to probability of A intersection B. And now see here, 4 minus 1 is equals to 3 by 4 is the probability of A intersection B. So we got probability of A intersection B, and we need to identify what? Probability of A into probability of B value. Now what? Consider. Now consider probability of A into probability of B, which is equals to value of probability of A is 1 by 2 into probability of B is 7 by 12, and which is equals to 7 divided by 2 into 12 is 24, and which is not equal to probability of A intersection B, since probability of A intersection B is 3 by 4. So finally we got probability of A intersection B is not equal to probability of A into probability of B. So since probability of A intersection B is not equal to probability of A into probability of B. So which implies A and B, given two events A and B are not independent events. Are not independent events. I hope all of you understood this. Now let's start the next question. And the next question is, given two independent events, given two independent events A and B, such that probability of A is 0.3 and probability of B is 0.6, then we need to identify the values: probability of A and B, probability of A and not B, probability of A or B, and last one is probability of neither A nor B. See here, first thing in this question, he has given that A and B are the independent events. See here, if A and B are independent events, are independent events, then definitely A dash and B also independent. A and B dash are also independent, and A dash and B dash are also independent. So you should know all these four things to solve this question. So if A and B are the independent events, then definitely A dash and B, A and B dash, and A dash and B dash are also what? Independent events. And also you know that if probability of A intersection B is equals to probability of A into probability of B, then we call that A and B are the independent events. So if A and B are the independent events, it means A dash and B also independent events. It means the condition of independent events for A dash and B dash is probability of A dash intersection B should be equal to probability of A dash into probability of B, and similarly remaining these two. Probability of A intersection B dash is equals to probability of A into probability of B dash, and probability of A dash intersection B dash is equals to probability of A dash into probability of B dash. So you should know all these 4 points to solve this given question. Now see here. So in this question, first we need to identify the value of probability of A and B. We need to identify what? Probability of A and B, probability of A, and means intersection B, and he has given A and B are the independent events. So it means probability of A intersection B should be equal to probability of A into probability of B, and which is equals to probability of event A is 0.3, so 0.3 into probability of B is 0.6, and which is equals to 0.3 into 0.6 is 0.18 is the value of probability of A and B, and we need to identify the value of probability of A and not B. Now what? Second question, probability of A, probability of A, and means intersection, not B means B dash. I hope all of you understanding. Now see here, since he has given that A and B are the independent events, it means A and B dash are also independent events. And we know that if A and B dash are the independent events, then definitely probability of A intersection B dash is equals to probability of A into probability of B dash. I hope all of you understand. Now which is equals to probability of A into probability of B dash can be written as 1 minus probability of B. Therefore, probability of A is given 0.3 into 1 minus probability of B is also given 0.6. So therefore, probability of A and not B is equals to 0.3 into 1 minus 0.6 is 0.4, and which is equals to 0.12. I hope all of you understanding. Now the third question. So here the third question is probability of A or B. Now what? Third question, probability of A or B. ಇಲ್ಲೇ ಮಾಡ್ತೀನಿ ನೋಡ್ರಿ, because we need some space. So now the third question, probability of A, R means union B. I hope all of you understand. So we need the value of probability of A union B. And we know that probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. So which is equals to probability of A is 0.3, he has given in the question, and probability of B is also 0.6. This is also given in the question, minus probability of A intersection B is we calculated, that is what? 0.18. Now 0.3 plus 0.6 is 0.9 minus 0.18. 0.9 minus 0.18 is equals to 90 minus 18 is equals to 72. So therefore this can be written as 0.72. The value of 0.9 minus 0.18 is equals to 0.72. And we need the fourth one. Here the fourth one is probability of neither A nor B. So here we need to identify the value of probability of neither A nor B. So neither A nor B is nothing but not A and not B. So neither A nor B, in other words, we call it as not A and not B. And hence the probability of neither A nor B can be mathematically represented as A dash intersection B dash. And by using the De Morgan's law, probability of A dash intersection B dash can be done as probability of A union B whole dash. And we know that probability of A union B whole dash is 1 minus probability of A union B, which is equals to 1 minus, we calculated the value of probability of A union B, which is equals to 0.72, and 1 minus 0.72 is equals to 80 plus 20, 100, it means 0.28. The required value of probability of neither A nor B is equals to 0.28. I hope all of you understood this question. Now let's start the next question. Two balls are drawn randomly with replacement. See here, in this question, two balls are drawn at random with replacement from a box containing 10 black balls and 8 red balls. Here is one of the box. Here is one of the box which consists 10 black balls and 8 red balls. From these balls, he is drawing 2 balls randomly in with replacement manner, and we need to find the probability of that both the balls are red, and probability of first ball is black and second ball is red, and we need to identify probability of one of them is a black and other is red. See here, there is a box which consisting 10 black balls and 8 red balls, and here two balls are drawn in which manner? In with replacement manner. With replacement manner means first he has to draw one ball from the box and then note down its color and then returns it to the box, and then only he has to go for the second ball to draw. So this is what with replacement manner. And now we need to identify the probability of both balls are red. Now the first question is what? Probability of getting both drawn balls are red are red. So it means probability of the first red ball and probability of the second red ball. So as you know that the total number of balls in the box, total number of balls in the box is equals to 18. Therefore probability of red ball is out of 18 balls 8 red balls. So probability of first red ball is 8 divided by 18 into, since the experiment takes place in a with replacement manner, therefore he has to keep this drawn ball to the box and he go for the second ball to draw. So therefore probability of getting the second red ball is, it is also divided by 18 because there is no changes in the total number of balls, and also number of red balls is also equals to 8 for the second ball. So 8 by 18 is the probability of second red ball. Therefore 2 fours are 8, 2 nines are 18. Similarly, 2 fours are 2 nines, which is equals to 4 fours are 16 divided by 9 nines are 81 is the probability of getting both balls are red. And we need to identify the probability of first ball is black and second is red. So in the second question, we need to identify the probability of, so required probability is equals to probability of the first ball is black and second is red, and second is red. So we need to identify probability of the first ball being black and second ball being a red. So here order of the two balls is given. First ball must be a black and second ball must be a red. So therefore probability of first black ball is out of 18 10 black balls. Therefore 10 divided by 18 is the probability of black ball into probability of red ball is 8 divided by 18. So which is equals to 2 5s are 2 9s are 2 4s are 2 9s are, which is equals to 20 divided by 81 is the probability of first ball being black and second ball being red. And now in the third question, we need to identify probability of one of them is a black and other is red. See here it doesn't given that the order of the balls is just given. We need to identify probability of getting one of the black balls and one of them is a red ball. So see here, when two balls are drawn from the box containing black and red balls, so that two balls may be black, or both of that two balls are red, or first is black second is red, or first is red second is black. So these are the only possibilities when two balls are drawn from the box which consisting 10 black and 8 red balls. So therefore here in the first question he has given that both the balls are red, it means we choose this one. First ball is red as well as the second ball is red. And in the second question, he has given that first ball is black as well as second ball is red. So that's why we choose the first ball is black and second is red. But here he has given that one of them is a black and one of them is a red. So it means required probability is equals to either black and red are red and black. Therefore, required probability is equals to probability of black and probability of red are in the sense rule of sum plus probability of red and probability of black. I hope all of you understood. Now see here, probability of getting black ball is 10 divided by 18. Probability of red ball is 8 divided by 18 plus probability of red is 8 divided by 18 into probability of black ball is 10 divided by 18. So which is equal to here 10 by 18 into 8 by 18, which is equal to 20 by 81. 10 by 18 into 8 by 18 is equal to 20 divided by 81 plus this is also same thing 20 divided by 81. So 20 plus 20 is 40 divided by 81 is the required probability. I hope all of you understood. And the next question is probability of solving a specific problem. See here, probability of solving a specific problem independently by A and B are 1 by 2 and 1 by 3. So here A and B refers to students. The probability of solving a specific problem by the student A is 1 by 2 and probability of solving that specific problem by the student B is 1 by 3. So here in this question he has given that probability of the solving that specific problem by the student A is equals to 1 by 2 and probability of solving that specific problem by the student B is 1 by 3 respectively if both try to solve the problem independently. If both the students A and B solve the problem independently, then we need to identify the probability of the problem is solved and exactly one of them solves the problem. See here, if suppose A and B, if suppose A and B are trying to solve the problem, then both of them may solve the problem or both of them may not solve the problem. It means A dash and B dash. A dash means probability of the specific problem is not solved by the person A or student A. B dash means probability of that specific problem is not solved by the student B. Or A may solve the problem but B may not. Or A may not solve the problem but B solves the problem. These are the only four case arises when the students A and B are trying to solve the specific problem independently. It is nothing but both may able to solve the problem or both may not able to solve the problem or any one of them will solve the problem. So but here we need to identify the probability of the problem is solved. So in the first question we need to identify probability of the problem is solved. Problem is solved. See here, just observe these four cases. In which case the problem is solved? In first case the problem is solved, both of them are solved here. And in third case also the problem is solved by the student A. And in fourth case also the problem is solved. Here the student B is solved the problem. So but except this second, in all the three cases, the problem is solved. It may be solved by both or anyone. But in these three cases, the problem is solved. Therefore, the probability of the problem solved is probability of A and probability of B or probability of A but not probability of B or probability of A not but probability of B. So in the first case, both of them are solved the problem. In second case, A is solved the problem. In third case, B is solved the problem. But in all these three cases, the problem is solved. Therefore, probability of the problem is solved is equals to probability of A is equals to 1 by 2 into probability of B is equals to 1 by 3 plus probability of A is equals to 1 by 2 into probability of B dash. We know that probability of B dash is equals to 1 minus probability of B and which is equals to 1 minus 1 by 3 which is equals to 2 by 3. Therefore, probability of B dash is 2 by 3 plus probability of A dash. Probability of A dash is equals to 1 minus probability of A which is equals to 1 minus 1 by 2 and it is equals to 1 by 2. So, therefore, 1 by 2 into, therefore, 1 by 2 into probability of B is 1 by 3. Now, see here, required probability is equals to 1 by 2 into 1 by 3 is 1 by 6 plus 1 by 2 into 2 by 3 is 2 by 6 plus 1 by 2 into 1 by 3 is 1 by 6, which is equals to 1 plus 2 3, 3 plus 1 4, so 4 by 6, which is equals to 2 by 3 is the required probability, that is the probability of problem is solved. And now we need to identify the, in second question we need to identify the probability of exactly one of them solves the problem. Now what? Probability of exactly one of them solves the problem. Solves the problem. It means either A solves the problem or B solves the problem, but not both. So therefore required probability is equals to CN. Any one means either A into B dash or A dash into B. Therefore required probability is equals to probability of A into probability of B dash plus probability of A dash into probability of B, which is equals to probability of A is 1 by 2 into probability of B dash is 2 by 3 plus probability of A dash is 1 by 2 into probability of B is 1 by 3, which is equals to 2 by 6 plus 1 by 6, which is equals to 3 by 6, and which is equals to 1 by 2 is the required probability. I hope all of you understood.